Today we're going to look at 1.1 and 1.3 notes, and this will deal with variables and how to write equations using variables and the difference between expression and equation. So first we're going to look at how many miles can you drive on a 10 gallons of gas. So this answer completely depends on what type of vehicle you drive. So we have 5 types of vehicles here: a subcompact, compact, a mid-sized sedan, sport utility, and a pickup truck. So just based on those, you can just Google how many miles they get in a whole tank of gas. So for a subcompact in a whole tank of gas, they get 330 miles. They can go pretty far in a full tank of gas. In a compact, they can go 300. In a mid-sized sedan, they can go 245. So that would be like your RAV4s and things like that. Sport utility, those bigger cars, 175, and then that pickup truck requires a lot more gas to go farther. So we're saying, and this isn't always accurate, but we're saying they all can hold 10 gallons of gas, which obviously isn't true, but for what we're doing today, we're going to act like all these cars only hold 10 gallons of gas. So if we were trying to find the miles per gallon, so if it can go 330 miles in 10 gallons, I want to know how much it can go in miles per that 1 gallon. Instead of right now, we know 10 gallons, I want to know 1 gallon, and this word per means 1. So if I want to know how much they can go in 1 gallon, think about what you would do with that 330 and that 10. I'm going to give you a second to think about it in your own mind. Okay, so hopefully you said you would take the 330 and you would divide it by the 10 gallons that you can use it on. And for 1 gallon, you can go 33 miles per gallon. Hopefully that's what you did. So I am going to let you do the rest based on what I just did. Try to figure out the rest, and I'll come back here in a second. So hopefully you said it is 300 divided by 10, which is 30 miles per gallon. You always want to label there. Hopefully with the next one you said 245 divided by 10 and got 24.5 miles per gallon, or 24.5 gallons. The next one, 175 divided by 10, and hopefully you got 17.5 miles per gallon. And on the last one, hopefully you got 16 miles per gallon. All right, so basically we've taken what we know and we've created this thing that we call equations. These are what we call equations. We have all the information we need in order to solve or to get an answer, which is why it's an equation. So the last column gives you a numerical. And the reason we call it numerical is because it has numbers. Sometimes you'll get an equation and it doesn't have numbers. And an equation has to be a mathematical sentence with an equal sign. In order to say that something's an equation, it has to have that equal sign. So that's why we can say all of these are equations, because they all have an equal sign. That leads to a number. It just can't be an empty equal sign. It can't say like 24 times 3 equals. It needs to have the answer to count as an equation. All right. So hopefully that's pretty clear. So let's move on to the bottom. So let's say you didn't know the number of miles. Let's say you're like, I got this new car. I don't know how many miles I can go, but I do know that it holds 10 gallons of gas. So you could use something we call a variable. A variable is used to stand for a number. So it's something of the unknown. That's why it can vary. It could be 10, it could be 20, but it varies because we don't know. Then you can write a variable expression. So an expression does not involve an equal sign. So let's say we want to write a variable expression for miles per gallon. Let's say we all know they hold 10 gallons, but we don't know how many miles it can go. So if miles is what we don't know, we're going to use a variable. You can use any letter you want. Typically it's A, B, or X. But in this situation, if it's going to represent miles, why not just use an N? Variables are always lowercase. It's always lowercase. So in this situation, our variable is an M because it represents miles. Now we can write a variable expression. So if you look up at the top, we took the miles and always divided it by 10 because that's how many gallons the car could hold. But in this situation, we don't know the miles, but we know there's 10 gallons. So we could just take the unknown miles and divide it by 10. That's a variable expression. It has a variable, but it doesn't have an equal sign. So all I've done is taken what we've done up here and wrote a variable expression. I don't know the number of miles, but I know it holds 10 gallons. So I'm taking my number of miles and dividing it by 10. Remember, you can always replay this if you have questions. You can go back and re-listen to it, so make sure you're doing that. All right, flipping to the back. So now we have discovered two good vocabulary words. A variable is a letter that stands for a number, and it's always lowercase. If you're going to struggle with that, you might want to write down that it's lowercase. Also, you might want to remember that your typical ones are going to be X, A, B, Y. Those are probably the most used variables. But remember, you can use any letter. The only letter I don't recommend is using an O because it can be confused with a 0. All right, and then the next vocabulary word is a variable expression. Is a mathematical statement that uses various numerals and operation symbols. So it has to have some letters, can have some numbers, and it can have any operation symbol you want, such as add, subtract, multiply, or divide. And it can have all of them, it can have one, it can have two, it can have as many as you would like. All right, I want you to pause the video at this point, and I want you to try to take this word phrase and write a variable expression. So I'll do the first one with you, and then I'm going to have you do the rest. 9 more than a number. So if we're saying 9 more than a number, do we know this number? Well, no, because it's not telling us. So we can use a variable to represent a number that we don't know. So I'm going to use A. You can use Y, you can use X, you can use any letter you want. So it's saying 9 more than A. So if I don't know A, but I know it's 9 more, well, mathematically I know more is adding. So A plus 9. That's all I'm looking for. All right, I'm going to give you a few minutes to work on that. And you need to pause the video because the video will move on. But you need to pause the video and try to fill out this table to the best of your ability. All right, hopefully you got that filled out. We are actually going to fill that out together in class, so that'll be where I see to make sure you've got this. All right, let's go down to the very last part. You can also evaluate a variable expression. There are 2 easy steps. So this is in a situation where it's a variable expression, but they tell you what the variable stands for. So they might tell you A is 8, they might tell you B is 4, something along those lines. They're basically going to tell you what the value of the letter is. So your first step, there's 2 easy steps. The first step is replace each variable with the correct number given. So if they tell you y equals 9, you need to replace the y with a 9. If they tell you x is 20, you need to replace the x with 20. If there's more than one variable, they're going to tell you what each variable is. Then you're going to use the order of operations to simplify, or in other words, to solve. All right, so let's take example 1 step by step. So first step, it says replace each variable with the correct number given. So evaluate 4y minus 15 for y equals 9. So it tells you right here, y is 9. So instead of y, I'm going to place a 9. And don't forget, when they're right next door to each other, that means to multiply. So I know this is saying 4 times 9 minus 15. Or you could always write 4 times 9 minus 15. Means the same thing, I'm just using parentheses on this side. All right, and then step 2 is use that order of operations. So there are parentheses, there are not exponents, there is multiplication or division. So 4 times 9 is 36. If you're doing it this way, same thing. And then 36 minus 15 is obviously 20. So your final answer here should have been 21. All right. Remember, you can always rewatch. You can always rewatch. This next one, 3ab plus c divided by 2 for a equals 2. I was underlining just so I don't forget. B equals 5 and c equals 10. And if you remember correctly, this is 3 times a times b, and then c divided by 2. So I'm first going to replace, because that's the first step. So instead of a, I'm going to put a 2. Instead of b, I'm going to put a 5. And instead of c, I'm going to put a 10. All I've done is replace the letters with their number value. All right? Follow my order of operations. There's no parentheses. There's no exponents. There is multiplication and division. Multiplication coming first. So 3 times 2 is 6 times 5 plus 10 over 2. There's still multiplication. 6 times 5 is 30. Well, now there's division, so I gotta do that. 10 divided by 2 is 5. 30 plus 5 is 35. Please rewatch this video as many times as you need to. Make sure that chart is filled in, and if you are confused, feel free to send me a message or wait to talk to me tomorrow. But watch this video as many times as you need. All right.